This lecture we are going to discuss regarding the queuing model, or it is also known as the waiting line model. So from the queuing model, from this we come across a term that is known as queue, a term that is known as queue. तो डे टू डे लाइफ में हम बहुत सारी जगह देखते हैं जहाँ एक क्यू बनी होती है जहाँ पे पीपल आर वेटिंग फॉर द सर्विस. सबसे पहले अगर हम एग्जांपल ले, we can take an example of a ticket counter where you can see a queue. Okay, this ticket counter can be a railway reservation counter, or it can be a metro ticket counter, or it can be a ticket counter at the cinema hall. Okay, you can see people are waiting in the queue to get the tickets. Okay, another example you can see is an ATM. ATM में भी क्या है, लोग खड़े होते हैं in the queue to withdraw the money from the ATM. Another example where you can see the queue is a bank. Okay, people come to the bank to get the service. Another example you can see is a hospital or a doctor's clinic. People, or rather the patients, are waiting in the queue so that they are able to meet the doctor and get the treatment from the doctor. Another example where you can see a queue is a restaurant. So people in the queue doesn't mean that people are standing in the queue. They can be standing in the queue, but they can also be sitting. Okay, restaurant mein people are sitting at the different tables. Okay, so but they are waiting to get the service. All यहाँ पे रेस्टोरेंट में जो सर्विस होती है, that is the people are waiting for the food. Okay, so in these examples we have seen that the elements which are waiting in the queue are human beings, but it's not necessary that the elements which are waiting in the queue are human beings. They can also be non-living things. Suppose machines. कोई एक प्रोडक्शन हाउस है, ओके, प्रोडक्शन कंपनी है या मैन्युफैक्चरिंग कंपनी है, वहाँ बहुत सारी मशीन्स होती है. सपोज आई टेक एन एग्जांपल दैट इन अ प्रोडक्शन यूनिट देयर आर 40 मशीन्स. सपोज 40 मशीन्स में किसी टाइम पे 10 मशीन्स ब्रेक डाउन हो गई, ओके, खराब हो गई. They need to get repair. Okay, obviously these 10 machines will be standing in a queue. Okay, they will be lined up in a queue to get repaired. तो यहाँ पे किसकी सर्विस हो रही है? द सर्विस जिसकी हो रही है वो मशीन्स की हो रही है जो ब्रेक डाउन हो गए और जिनका फेलियर हुआ. Similarly, if we take an example of another non-living object which is in the queue, that is an example of the vehicles. Okay, vehicles या cars. ठीक है, सपोज हम एक एग्जांपल लेते हैं एक सर्विस स्टेशन की. वहाँ पे बहुत सारी गाड़ियाँ आती है टू गेट सर्विस्ड, और कार वॉशिंग के लिए आती है, जो भी है. सो दोज एलिमेंट्स which are arriving at a station to get serviced are not human beings, but they are non-living things like machines, vehicles. Okay, there can be other examples as well. So if you see the schematic, the customers arriving, now these customers can be living beings, or they can also be the non-living things like machines or vehicles. You can see these dots. Okay, these are the customers or the elements which are arriving and they are waiting in the queue. अब यहाँ पे इस बॉक्स में जो बने हैं, दिस इज द सर्विस फैसिलिटी जहाँ पे सर्विस मिल रही है. ओके, and after that the customers are leaving. Okay, so you can see that the customers are arriving and customers are waiting in the queue, and some customers are getting serviced. Okay, once these customers are getting serviced, these customers will leave the system, and the customers which were waiting in the queue are coming into the service facility. Okay, so what is written here is this model provides an economic balance between the cost of providing service and the waiting cost. Okay, see in this slide, the cost of waiting customers generally includes either the indirect cost of loss of business, okay, or direct cost of idle equipment. Okay, so cost of waiting, this involves two terms. One is the cost of loss of business, another is the direct cost of idle equipment. Okay, so इस indirect cost की बात अगर हम करें, so see here, if people are going to a restaurant, अगर कुछ लोग रेस्टोरेंट में जा रहे हैं, उस रेस्टोरेंट में बहुत सारा टाइम लग रहा है टू गेट द फूड. ओके, सपोज कोई इंसान, a person goes into a restaurant. Okay, it takes suppose 30 minutes for the food to arrive. Okay, obviously then this person won't prefer going to this restaurant again. Okay, because the service takes a lot of time. Okay, the service is going to take a lot of time. Okay, so ये कस्टमर नेक्स्ट टाइम इस रेस्टोरेंट में प्रेफर नहीं करेगा आना. दैट मीन्स दिस इज काइंड ऑफ अ लॉस फॉर द रेस्टोरेंट. ओके, see again, the cost of waiting means it is either an indirect cost, okay, of lost business because people go somewhere else. Okay, people will go somewhere else. Okay, so जैसे ही वेटिंग कॉस्ट बढ़ जाता है. Okay, or rather you can see that on this x-axis there is increased service. So जितनी better service होगी, the waiting cost is going to decrease. Okay, so कहीं पे अगर यहाँ पे देखिए this point, and if I take an example of this point, यहाँ पे जो सर्विस है, the level of service is not good. Okay, the level of service is not good, so the waiting cost is very high. Okay, ओके, यही एग्जांपल मैंने अभी ली रेस्टोरेंट की कि यहाँ पे काफी टाइम लग रहा है फॉर द फूड टू अराइव. दैट इज द सर्विस कुछ अच्छी नहीं है यहाँ पे. तो सर्विस जब अच्छी नहीं है, सो दिस इज एन इनडायरेक्ट लॉस टू द रेस्टोरेंट और एनी अदर बिजनेस यूनिट. ओके, बिकॉज इट इज मेकिंग द पीपल टू वेट. सो वेटिंग की वजह से जो है कॉस्ट बढ़ रहा है. सो इट्स नॉट अ डायरेक्ट कॉस्ट, ओके, but it is an indirect cost because a kind of a goodwill is not there. Okay, there is not a goodwill because I told you that this customer will prefer going to some different restaurant where he will get a better service. Okay, or see here, another is the direct cost of the idle equipment. Okay, direct cost of the idle equipment. So किसी प्रोडक्शन यूनिट में मशीन्स ब्रेक डाउन हो गई, अगर उनकी सर्विस जल्दी से जल्दी ना हो तो वो क्या रहेंगे, द machines will remain in the queue. Machines are remaining in the queue, that is the machines are waiting in the queue. Machines are waiting in the queue is that प्रोडक्शन सिस्टम बंद हो गया. ठीक है, अगर कोई मशीन बैठ गई उसकी वजह से प्रोडक्शन सिस्टम बंद होगा. सो दैट इज ऑल्सो गोइंग टू इंक्रीज द कॉस्ट. ओके, वेटिंग कॉस्ट बढ़ जाता है बिकॉज इस दौरान अगर उसकी उस मशीन की जल्दी से सर्विस की जाती, सो द मशीन कुड हैव बीन इन द रनिंग मोड अगेन एंड द प्रोडक्शन वुड हैव रिज्यूम्ड. तो प्रोडक्शन का नुकसान नहीं हो जाता. बट आई होप यू आर गेटिंग व्हाट आई एम ट्राइंग टू से. तो जहाँ पे ज्यादा बेटर सर्विस होगी वहां पे क्या होगा, वेटिंग कॉस्ट विल बी लेस. यू कैन सी दैट दीज आर इनडायरेक्टली प्रोपोर्शनल. ओके, जहाँ पे बेटर सर्विस होगी तो वेटिंग कॉस्ट कम होगा, जहाँ पे खराब सर्विस होगी वहां पे वेटिंग कॉस्ट इंक्रीज हो जाता है. ओके, so you can see that this illustrates relationship between the level of service provided. Okay, if there is a good service there will be less waiting time. Okay, sorry, waiting time cost. So here you can see that it is observed as the level of the service is increased. Okay, the waiting cost is going to decrease. See here, now when you are increasing the service, okay, when you are increasing the service, the cost of providing service is also going to increase. ठीक है, so किसी रेस्टोरेंट में अगर एक शेफ है, okay, he is making all the food. So अगर किसी रेस्टोरेंट में बहुत सारे waiters है और there are various chefs, okay, more number of chefs, obviously the cost is going to increase because उनको salary provide करनी है. Okay, you have to provide the salary to the chefs or the waiters. But so when you are increasing the service, the cost of providing service is also going to increase. But when you are increasing the service, the waiting cost is going to decrease. Okay, so increasing service at at ठीक ठीक है. So अगर आप देखेंगे, जब आप सर्विस इंक्रीज करते हो, at one hand it is going to decrease the waiting cost, but when you are increasing the service, at the other hand it is going to increase the cost of providing service. Okay, so increasing cost decreases the waiting cost, but it increasing the cost of providing the service. Okay, you can see that in this figure is illustrated the relation between the level of service and the cost of providing that service. It is observed that the level of service increases, so does the cost of providing service also increases. Now, so there has to be an economic balance. यही मैंने पहले स्लाइड में आपसे कहा था. This model provides an economic balance between the cost of providing service and the waiting cost. Okay, so if you combine these two curves, okay, and this is the first curve where we have a waiting time cost, and this is a second graph where we have cost of providing the service. If you're going to merge them, you come across this. Okay, ये हमने देखा. This is for the waiting cost. Okay, this is for the waiting cost, and this is for the cost of providing service. If you are going to combine these two okay graphs, you are going to get a total cost. Okay, this total cost is equal to the summation of cost of providing service plus waiting time. Okay, इन दो का summation, ठीक है, इस कर्व और इस कर्व को मिलाकर हमें एक कर्व मिलती है, that is known as the total expected cost. So you can see that this point is a point of minimum. Okay, here the cost is high. Now this cost is going to decrease, and after that it is again going to increase. Okay, so just pay a minimum hoga. Okay, obviously we would like to get a minimum cost. Okay, we'll like to get a minimum cost. Okay, so there is an optimum level of service. ये क्या है यहाँ पे? This axis is of the service axis. Okay, so this gives us the idea of what kind of service should we provide to the customer so that our total cost is minimized. Okay, so you can see that initially when the level of service is down, the cost is high. As you are increasing the level of service, the cost is going to decrease. But if you further increase the level of service, the cost is again going to rise. So we come across a point where the level of service, okay, this will be the optimum level of service. Okay, this will be the optimum level of service. Okay, जहाँ पे हमें क्या मिलता है? The minimum cost. Okay, so therefore in the initial slide I told you the goal of queuing model is to find an economic balance between the waiting cost and the cost of providing the service. So elements of a queuing system or the structure of a queuing system. एक queuing system में क्या क्या चीजें होती है? Okay, these are the 7 elements of a queuing system: input, output, service channels, service discipline, maximum number, calling source of population, and customer behavior. So let's look at them one by one. Arrival distribution. The first is arriving. So the customers are arriving at a facility to get service. Okay. So arrival distribution, it represents the pattern in which the number of customers arrive at this service facility. Okay. Arrivals may also be represented by the inter-arrival. Okay. So you can see that there is a term which is known as the arrival rate. And this arrival rate is represented by the symbol lambda. Okay. And this lambda is defined as the number of customers arriving per unit of time. Okay, so how many customers are arriving at a given instant of time or at a given amount of time, that is known as the arrival rate. Okay, so see, if I take an observation, कोई एक ATM हम देखते हैं, a person is observing an ATM. He is seeing the ATM at 10 a.m. Okay, and he's also seeing the ATM at 5 p.m. So if you look at the instance of time that has passed, okay, from 10 a.m. to 5 p.m., the time elapsed is 7 hours. So यहाँ पे जो observation कर रहा है, कोई बंदा यहाँ पे observation कर रहा है, he says that 140 customers have come during this time. Okay, 140 customers have visited the ATM during this time. Then we can say that the arrival rate here is equal to number of customers which are visiting और कितने टाइम में ये कस्टमर विजिट हो रहे हैं. So we will get that this will be equal to 20 customers per hour. So this is the arrival rate. Obviously 20 customers are coming per hour. Okay, तो 7 घंटे में कितने आएंगे? 20 into 7, that is equal to 140. So this is the arrival rate. And the arrival is assumed to follow the Poisson distribution. Okay, different जगह different पैटर्न में लोग आते हैं. ठीक है, एटीएम में एक पैटर्न में लोग आएंगे, टिकट काउंटर पे दूसरे पैटर्न में लोग आएंगे. ओके, रेस्टोरेंट में दूसरे पैटर्न में लोग आएंगे. अगर आप देखोगे रेस्टोरेंट में ज्यादा पॉसिबिलिटी कब होती है लोग आने की? लंच टाइम एंड डिनर टाइम. ओके, so at lunchtime and at the dinner time you can see a rush of people. Okay, so since this arrivals are random, okay, the arrivals are random, you can't predict the arrival. Okay, you can't predict the arrival. The probability distribution okay, which we have given to this is the Poisson distribution. Okay, we say that the arrival pattern follows the Poisson distribution. Okay, different चीज में क्या होता है, different जगह पे different distribution होता है, but currently we are studying the model which is known as Markovian model. Okay, I will explain it later on. So here we assume that the arrival pattern is what is Poisson distributed. Okay, the arrival pattern is Poisson distributed. So this arrival is governed by a term that is known as the arrival rate, which is very important, and this is represented by the term lambda. Okay, and this lambda is defined as the number of customers which are arriving per unit time. Okay, I have given an example here. Another thing here is the inter-arrival, and that inter-arrival is given by the reciprocal of the arrival. Okay, this term is known as the inter-arrival rate. ठीक है, इंटर अराइवल रेट। और ये क्या होता है, इट इज द रिसिप्रोकल। अगर अराइवल रेट होता है कि कितने कस्टमर पर यूनिट टाइम में आ रहे हैं, तो इसका रिसिप्रोकल क्या होगा, इंटर अराइवल रेट का जो यूनिट होगा दैट विल बी आवर्स पर कस्टमर। कितने घंटे के बाद एक कस्टमर आता है। ओके, सो clearly see what is the difference between arrival rate. Arrival rate means number of customers arriving per a unit of time, कि एक यूनिट टाइम में कितने कस्टमर आ रहे हैं। यहाँ पे हमने यूनिट क्या लिया है, यहाँ पे हमने यूनिट लिया था आवर। तो एक घंटे में कितने कस्टमर्स आ रहे हैं, 20 कस्टमर्स आर कमिंग पर आवर, देन इट इज द अराइवल रेट। बट कितने टाइम के बाद एक कस्टमर आता है, दैट इज नोन एज व्हाट, दैट इज नोन एज इंटर अराइवल रेट, और इट्स यूनिट कैन ऑल्सो बी मिनट पर कस्टमर। Okay, its unit can also be what, minutes per customer. Okay, so you have to clearly see in the question whether arrival rate or inter arrival rate is given, because you need to find out the lambda. Okay, sometimes lambda will be directly given in the question, but sometimes question will be twisted in such a matter, in such a manner that he has given the inter arrival rate. Okay, suppose यहाँ पे कोई ऑब्जर्व करा है। Okay, I will give you an explanation of the inter arrival rate. There is a person which is observing एक क्यूइंग फैसिलिटी वो ऑब्जर्व कर रहा है। वो यहाँ पे देख रहा है दैट एट सपोज टाइम इक्वल टू, सपोज यहाँ पे दिख रहा है 10 बजे, 10 बजे यहाँ पे एक एटीएम में कोई कस्टमर आया हुआ है। ठीक है, तो नेक्स्ट कस्टमर वो देख रहा है, he is seeing that the next customer is coming at 10:15. Okay, he sees one customer at 10 and he sees that next customer is at 10:15. तो इन दो के दरमियान, ठीक है, कस्टमर कब आया। ओके, you can see that the customer is coming after 15 minutes. Then कितना टाइम लग रहा है पर कस्टमर। ओके, यहाँ पे एक कस्टमर 10 बजे था, दूसरा कस्टमर यहाँ पे ये दिख रहा है 10:15 पे आ रहा है। सो द टाइम गैप बिटवीन द अराइवल ऑफ ए न्यू कस्टमर इज 15 मिनट्स। सो ये दिख रहा है कि 15-15 मिनट के बाद एक एक कस्टमर आ रहा है। ओके, एक कस्टमर आया, अब ये दिख रहा है कि 15 मिनट के बाद दूसरा कस्टमर कस्टमर आया, उसके बाद ये दिख रहा है कि 15 मिनट के बाद और एक कस्टमर आया। सो ही कैन सी दैट आफ्टर एवरी 15 मिनट्स a customer is arriving. Then 15 मिनट्स पर कस्टमर, 15 मिनट लग रहे हैं एक नए कस्टमर को आने में। ओके, 15-15 मिनट के बाद एक नया कस्टमर आ रहा है। Then you can see that 15 minutes per customer, minute per customer means it is not the arrival rate, it is what, it is the inter arrival rate. So this 15 minutes per customer is not the arrival rate, it is the inter arrival rate, which is represented by 1 by lambda. Okay, I hope it is clear. Arrival rate क्या होता है, नंबर ऑफ कस्टमर्स पर यूनिट टाइम। इंटर अराइवल मींस कि कितने टाइम के बाद नया कस्टमर आता है। ओके, एंड दैट इज रिप्रेजेंटेड बाय 1 by lambda and its unit is minutes per customer or hours per customer. Okay, so this is regarding the arrival. Now similarly the service, okay, this service Okay, it represents the pattern in which the number of customers leave the service facility. Number of customers leave the service facility depends upon the person who is providing the service. Okay, अराइवल तो किस पे डिपेंड है, जो लोग आ रहे हैं उन पे डिपेंड है, लेकिन सर्विस किस पे डिपेंडेड है, जो पर्सन सर्व कर रहा है वहां पे. ओके, सो departure or service can be represented by a parameter which is known as what, service rate, and service rate is denoted by mu. Okay, obviously the this will be the number of customers leaving. Okay, okay, number of customers serviced. Okay, the number of customers which are getting serviced per unit of time is known as the service rate. Arrival rate, number of customers arriving per unit time, whereas the number of customers getting serviced per unit time is known as what, service rate. जैसे हमने देखा कि arrival pattern follows what, arrival pattern follows the Poisson distribution. Okay, one thing I forgot here is arrival pattern. Okay, arrival, this follows Poisson distribution, whereas the inter arrival follows negative exponential distribution. ठीक है, ये यहाँ पे लिखा भी है. Okay, you can see that the mean arrival rate, okay, negative exponential. Okay, the inter arrival follows negative exponential. Okay, arrival follows the Poisson distribution, whereas the inter arrival pattern follows the exponential distribution, and more particularly negative exponential distribution. Similarly here in this case, the service rate, okay, it follows negative exponential. Okay, this thing follows negative exponential distribution. यहाँ पे लिखा होगा. Okay, exponential probabilistic distribution. Okay. Okay, arrivals are Poisson distributed, whereas the service is negative. This what we call as the exponential distributed. Just like we have service rate, we also have inter service rate. वहां पे क्या था, इंटर अराइवल. इंटर अराइवल मीन्स कि कितने टाइम बाद एक कस्टमर आ रहा है. यहाँ पे अगर हम बात करें इंटर सर्विस की, ओके, दिस इज व्हाट, इंटर सर्विस रेट. कितने टाइम के बाद अब कस्टमर की सर्विस हो रही है. सपोज यहाँ पे एक इंस्टेंट है, यहाँ पे दूसरा इंस्टेंट है. सो यहाँ पे एक पर्सन ने ऑब्जर्व किया कि 10 बजे एक पर्सन की सर्विस हुई, तो वो दिख रहा है कि 10:10 पे दूसरे पर्सन की सर्विस हो गई. सो व्हाट इज द गैप बिटवीन, इट इज इक्वल टू व्हाट, 10 मिनट्स. इसका मतलब क्या है, द इंटर सर्विस रेट इज इक्वल टू व्हाट, 10 मिनट्स पर कस्टमर. ओके, इट्स इक्वल टू व्हाट, 10 मिनट्स पर कस्टमर. ठीक है, सो 10-10 मिनट के बाद एक एक कस्टमर की सर्विस हो रही है. ओके, सो अराइवल लैम्डा. ओके, नंबर ऑफ कस्टमर्स अराइविंग पर यूनिट टाइम. 1 by lambda is inter arrival, नंबर ऑफ कितने टाइम के बाद एक कस्टमर आ रहा है. ओके, इंटर अराइवल, अगेन मूव टू द प्रीवियस स्लाइड. कितने टाइम के बाद एक कस्टमर आ रहा है, दैट इज 1 by lambda. अब सर्विस, ओके, सर्विस रेट इज व्हाट, नंबर ऑफ कस्टमर्स गेटिंग सर्विस्ड पर यूनिट टाइम. और इसका जो यूनिट होता है, इसका जो यूनिट होगा दैट इज कस्टमर पर आवर और कस्टमर पर मिनट. लेकिन इंटर सर्विस का क्या होगा कि कितने मिनट बाद एक कस्टमर की सर्विस हो रही है, इसका यूनिट क्या होगा, आइदर इट कैन बी मिनट पर कस्टमर और आवर पर कस्टमर, कि कितने टाइम के बाद किसी पर्सन की सर्विस हो रही है. ओके, सो रिमेंबर, अराइवल रेट फॉलोज पॉइजन डिस्ट्रीब्यूशन, इंटर अराइवल फॉलोज नेगेटिव एक्सपोनेंशियल डिस्ट्रीब्यूशन. But here, service follows the service follows the negative exponential distribution, whereas this inter-service, okay, this is inter-service, it follows the Poisson distribution. Okay, quite easy to remember. Okay, arrival lambda Poisson. Okay, 1 by lambda is inter-arrival, that is negative exponential. Service mu follows the negative exponential, whereas 1 by mu, that is the inter-service that follows the negative, this Poisson distribution. Okay, so I hope these two elements are clear to you. Okay, so service channels. Okay, you can see, you can read this text, and I can give you the example. This is an example of single channel and single phase. Okay, you can see that mm, there are some people waiting in the queue. These circles represent the people waiting in the queue, and this is a service facility. Okay, this is a service facility. So अगर हम किसी की बात करें, सपोज एक टिकट काउंटर है. ओके, द पीपल आर वेटिंग इन द क्यू. They are getting the ticket from a single person. Okay, a single person is providing the tickets. Okay, so this channel is known as what? Single channel and a single phase. Okay, single channel and single phase. Now here you can see that there is there are people waiting in the queue. Okay, they are waiting in the queue. There are two service facilities. There is the first service facility. उसके बाद ये person दूसरी service facility पे जा रहा है. Let me take an example. So पहले एग्जांपल, एक एग्जांपल लेते हैं किसकी, हम सपोज बैंक की. बैंक में सपोज ये एक एटीएम सेक्शन में जाता है. देयर इज एन ऑफिसर व्हिच इज डीलिंग विद द एटीएम सेक्शन. उसके बाद ये किसी और सेक्शन में जा रहा है. ओके, सपोज ये यहाँ पे ही इज गोइंग टू मीट द बैंक मैनेजर. ओके, ब्रांच मैनेजर ऑफ दैट बैंक. ओके, so the people in the queue, they are, first of all, they have to pass through a section. Okay, where they are going to get a service from the first facility. Okay, there is an officer which is associated with the ATM facility. Okay, he is going to get the service from this facility, and after that he is going to get the service from the bank manager. Okay, so यहाँ पे क्या था, ऊपर वाले में केस में सिंगल चैनल एंड सिंगल फेज. यहाँ पे भी क्या है, चैनल इज, देयर इज अ सिंगल चैनल बट देयर इज मल्टी फेज. दैट इज he has to get the service at the multiple locations. अगर हम यहाँ पे बात करें, यहाँ पे क्या है, he has to get a, see here now, there are multiple channels. Okay, there are multiple channels. Okay, but there is a single phase. Okay, there is a single phase. Okay, see here, कोई एक टिकट काउंटर है जहाँ पे ज्यादा भीड़ रहती है. देयर इज अ सपोज रेलवे स्टेशन जहाँ पे ज्यादा भीड़ रहती है. सो अ सिंगल सर्वर, यहाँ पे क्या था, यहाँ पे भी मैंने एग्जांपल ली थी रेलवे स्टेशन की, बट दिस इज अ स्मॉल रेलवे स्टेशन. अ सिंगल पर्सन इज इशूइंग द टिकट्स. लेकिन यहाँ पे क्या है, यहाँ पे टू पर्सन आर इशूइंग द टिकट्स. दोनों क्या दे रहे हैं, सेम टिकट दे रहे हैं. ठीक है, सो क्यू में जो लोग खड़े हैं, कोई एक पर्सन यहाँ पे जाएगा. कहाँ पे जाएगा, from a service facility which is the same as that this service facility. Okay, both are providing the same tickets. Okay, बट यहाँ पे इस रेलवे स्टेशन पे क्या होगी, सपोज ज्यादा भीड़ होगी, उसकी वजह से यहाँ पे इन्होंने एक के बदले दो सर्विस प्रोवाइडर्स रखे होंगे. ओके, अब यहाँ पे क्या है, देयर आर मल्टीपल चैनल्स. ओके, बट देयर आर मल्टीपल चैनल्स, लेकिन फेज क्या है, सिंगल फेज है. दैट इज बोथ आर प्रोवाइडिंग द सेम सर्विस. नाउ इफ वी मेक एन combination of all these, we can have a multiple channel and multiple phase. Okay, see here, this यहाँ पे पहले ही पता चल जाता है there is a multiple channel. और यहाँ पे okay, suppose a person is getting serviced here, उसको उसके बाद दूसरी सर्विस फैसिलिटी में भी जाना है. दैट इज, दिस इज अ केस ऑफ मल्टीपल फेज. ओके, यू कैन सी हियर, यहाँ पे सिंगल चैनल थी और मल्टीपल फेज था. पहले इसको यहाँ पे जाना था, फिर दूसरे सर्विस प्रोवाइडर के पास जाना था. यहाँ पे भी इसको एक सर्विस प्रोवाइडर के पास जाना है, उसके बाद दूसरे सर्विस प्रोवाइडर के पास भी जाना है. लेकिन यहाँ पे क्या है, मल्टीपल चैनल्स भी हैं. ओके, यहाँ पे भी क्या होगा, द स्टेशन विल बी अ काइंड ऑफ अ बिजी स्टेशन. ओके, so this is what, this is regarding the service channels. Okay, so you can read this text. I have explained the text from the schematic. Now going on to the next. Okay, the fourth element is the service discipline. Okay, service discipline is the rule by which the customers are selected from the queue for the service. Okay, so सबसे पहला service rule क्या होता है, that is FIFO, that is first in first out. Okay, the person coming first will be serviced. Okay, FIFO. This service is also known as what, FCFS, first come first serve. Okay, सो दिस इज वन सर्विस डिसिप्लिन. अगर हम बात करें, okay, LCFS, this is known as what? Last come first serve. This is another discipline in which there can be the treatment of this uh, persons from the queue. Okay. Another is what? SIRO. You can see that SIRO, service in random order. किसी को भी सर्विस उठा के, ओके, क्यू में से किसी को भी उठा के सर्विस दे सकते हैं. ओके, दिस इज द सर्विस इन रैंडम ऑर्डर. एंड अनदर इज प्रायोरिटी. ओके, समटाइम्स क्यू में किसको प्रायोरिटी दी जाए. ओके, आई विल गिव यू एन एग्जांपल दैट some people are waiting at the drug store of the hospital. ठीक है, किसी को पर्सन को एक सिंपल हेडेक के लिए मेडिसिन चाहिए, किसी को एक एस्पिरिन चाहिए. सपोज a person has suffered some heart stroke or brain stroke. Okay, उसको अचानक से क्या चाहिए, उसको जितना जल्दी एस्पिरिन का डोज दिया जाता है, he can recover fast. So अगर हम प्रायोरिटी की बात की जाए, obviously the person which is requiring a tablet of headache, simple headache, is not that much of importance as compared to the one which has come to take the medicine of aspirin. तो वहाँ पे हम क्या करते हैं, एक प्रायोरिटी ट्रीटमेंट देते हैं. ठीक है. So this is regarding the service discipline. Okay, so this is regarding the service discipline. So you can have first in first out, you can have last come first in, you can service in the random order, or you can have the priority based service. Okay, another element is the capacity of the system. Maximum number of customers in the system can be either finite or infinite. In some facilities, only a limited number of customers are allowed in the system, and the new customers arriving are not allowed to join the system unless the number of becomes less than the limiting value. Okay, so system की capacity कहीं पे finite हो सकती है, कहीं पे infinite हो सकती है. Okay, so if we take an example of the ticket counter, वहाँ पे बहुत सारे customers आ सकते हैं. There is not a limit that only 10 customers are going to get the tickets. Okay, in the railway station there can be a number of people which are coming to the system. लेकिन suppose कोई example हम लेंगे, there is a doctor which is going to see only 10 patients per day. Okay, so obviously only 10 people will be allowed to enter the system. Then we can say that the capacity of the system is finite. Whereas in that case of the restaurants, or in the case of this ticket counters, okay, लोग आते हैं लोग जाते हैं, so infinite number of people can come and go. There is not any restriction. So we can see that the capacity of the systems, that is the maximum number of customers that are allowed in the system. Another is the calling population. Okay, calling source or population. Calling population usually हम इसको कहते हैं. So calling population means the arrival pattern of the customers depends upon the source which generates them. Okay. Okay, calling source or calling population, the arrival pattern of the customers depending upon the source which generates them. Okay, तो लोग कहाँ से आते हैं to get the service. Okay, that is known as the calling population. Okay, it is the group from which the customers, अगर हम कुछ different term में इसको define करें, it is the group from which the customers can come and get serviced. Okay, so calling population is the source of the arrivals. लोग कहाँ से आ सकते हैं. Okay, so this calling population can also be finite or infinite. Okay, suppose कोई हॉस्पिटल है या कोई रेस्टोरेंट है, वहाँ पे कहीं से भी लोग आ सकते हैं. Okay, there isn't any restriction that कि लोग यहाँ से आ जाएं. Okay, but sometimes there is a restriction. अगर हम बात करें एक एक रिपेयर कर रहा है. ओके, सपोज देर इज अ प्रोडक्शन यूनिट. ओके, देर इज अ प्रोडक्शन यूनिट, कोई कंपनी है, वो कुछ प्रोडक्शन या मैन्युफैक्चरिंग यूनिट है, उसमें एक रिपेयर शॉप है. ओके, देर इज अ रिपेयर सेक्शन जहाँ पे उन मशीन्स का रिपेयर होता है जो ब्रेक डाउन हुई है उस प्रोडक्शन यूनिट में. सो ऑब्वियसली फॉर हिम द calling source or population is लिमिटेड और फाइनाइट, बिकॉज उसको पता है कि मेरे पास वो मशीन्स आएंगे जो इस प्रोडक्शन यूनिट में ब्रेक डाउन होंगे। ठीक है। तो रेस्टोरेंट वाले को मुझे नहीं पता है कि लोग कहाँ से आएंगे। देयर कैन बी इनफाइनाइट नंबर ऑफ सोर्सेज फ्रॉम विच द पीपल कैन कम इनटू द रेस्टोरेंट, या हॉस्पिटल में कहीं कहीं से भी लोग आ सकते हैं। ओके, so we can say the calling source or population for that is infinite. Okay, but for a machine breakdown in a particular production unit, the repair section, उस रिपेयर सेक्शन में क्या आ जाएंगे, उसको पता है कि इस यूनिट की मशीन्स अगर ब्रेक डाउन होगी तो वो मेरे पास रिपेयर के आएंगे। लेकिन उसको पता है कि दैट द कॉलिंग पॉपुलेशन और द कॉलिंग सोर्स इज लिमिटेड और रिस्ट्रिक्टेड। So third, the last is the customer behavior. Okay, how the customer behaves. The customer behavior is also very important in the study of queues. If the customer does not enter the queue, since the queue is too long, he is said to have balked. Okay, balking means that, okay, a customer aa gaya, he sees that the queue is very long, so he is not interested in joining the queue. Then we can say that the customer is balked. Okay, or balking means what? Leaving the queue without joining the queue because the queue is very long. Okay, sometimes there's another term that is known as ranging. ओके, कोई कस्टमर आया, वो बैठा क्यू में कुछ देर के लिए, फिर देख रहा है नहीं ये क्यू बहुत लंबी है, और दिस क्यू इज नॉट प्रोग्रेसिंग एट अ गुड रेट। ओके, ही सिंपली लीव्स द क्यू। ओके, व्हाट इज द डिफरेंस बिटवीन बाल्किंग एंड रेंजिंग? बाल्किंग में क्या होता है दैट the person sees that the queue is long, he doesn't join the queue and he leaves the queue. He just simply does not join the queue. But in the ranging case, the customer may join the queue for some amount of time, but he sees that the queue is progressing very slowly, so he is leaving the queue. Okay. अगर कहीं पे क्या होते हैं, दो तीन queues parallel में चलती हैं. Okay, there are three queues. Okay, if a customer comes, he joins this queue for some amount of time, उसके बाद ही इस queue में चला जाता है. Okay, he just keeps wandering from one queue to another, then we can say that person is jogging. Okay, that person is jogging. There's one more class of the customer that is known as the cheater. Okay, cheater means what? He bribes the people, or just or involves in some fighting or argument to get the service faster. Okay, although it's not mentioned here, but another way to classify the customer behavior is a cheater. Okay, so we have seen balking, jockeying, ringing, and cheater. Now there is very much important parameter, okay, which is defined by rho. This rho gives us the ratio of the arrival rate and the service rate. Okay, simply it is what? A ratio of arrival rate to service rate. And this thing is known as what? This term rho is known as utilization factor. Okay, this is known as what? Utilization factor. Okay, this is known as what? Utilization factor, or sometimes it is also known as traffic intensity. Okay, extremely important parameter. It gives us the probability that the server is busy. Okay, so this is going to give us the probability that the server is busy. Okay, so see here, if at a particular station the arrival rate is, suppose 10 customers are coming per minute or per hour. Okay, and if the service rate is 15 customers are being serviced per hour. Okay, if we calculate this ratio, then it will be equal to 10 by 15. that will be equal to 2 by 3, that is near about equal to 0.67. Okay, so this 0.67 is the probability that the server is busy. Okay, probability that the server is busy. Okay, so इट्स क्वाइट क्लियर दैट कि अगर कहीं पे 1 घंटे में 10 कस्टमर्स आ रहे हैं और लेकिन उसकी सर्विस रेट ज़्यादा है. ओके, see here the service rate is greater, isn't it? Mu is greater than lambda, that is the rate at which the customers are getting serviced is greater than the rate at which the customers are arriving. Obviously अगर 1 घंटे में कितना है, okay, you can see that this rate is, the service rate is greater. Okay, so obviously per hour, ओके, 1 घंटे में अगर 10 ही आ रहे हैं लेकिन सर्विस बहुतों की हो रही है. ओके, सो डेफिनेटली देयर विल बी सम रिलैक्स टाइम. ओके, देयर विल बी सम रिलैक्स टाइम और द टाइम वेयर विच द सर्वर विल बी आइडल. ठीक है, so 2 by 3 means 0.67. This means that for 67% of time the server is going to be busy, whereas during the remaining 33% of time the server is going to be idle. Okay, the server is going to be idle. So probability that the server is busy is given by rho, whereas the probability that server is idle is given by p naught. That will be equal to 1 minus mu. Okay, the probability that the server is busy is given by this rho. Okay, whereas the probability that the server is idle is represented by p naught, and that is given by 1 minus rho. Okay, probability that server is idle. ओके, सो इन दिस केस, ओके, जो मैंने एग्जांपल यहाँ पे ली थी जहाँ पे अराइवल रेट 10 थी और दिस सर्विस रेट वाज 15, if we calculate the probability that the server is busy, that is given by rho, that is equal to 0.67. And if we calculate the probability that the server is idle, then it will be obviously given by 1 minus rho, that will be equal to 0.33 in this case. Okay, so it's actually a simple concept that probability that a person is busy. Okay, a person can be busy or he can't be busy. Okay, probability that the server is busy or probability that the server is not busy or any person is not busy, that is equal to 1. Okay, so probability that a server is busy will be equal to 1 minus probability that the server is not busy. Okay, or we can say that the probability that the server is not busy is equal to 1 minus probability that the server is busy. Okay, probability that the server is not busy is given by p naught, then it will be equal to 1 minus probability that the server is busy, which is given by rho. Okay, so this is regarding the utility ratio. Okay, so it is known as what? Utilization factor, traffic intensity, and sometimes it is also known as utility ratio. Okay, you can come across various terms for this rho. Okay, very important term, that is rho. So suppose if you see that if lambda is equal to mu, okay, उसका मतलब क्या है? Lambda is equal to mu is that service rate is equal to the arrival rate. Okay, जिस रेट से लोग आ रहे हैं और उसी रेट से लोगों की सर्विस हो रही है, then lambda by mu will be equal to 1. Okay, because lambda and mu are equal. Okay, then rho is equal to 1. This implies that probability that server is busy, okay, that is 100%. Okay, that is equal to 1 or 100%. That is सर्वर हमेशा बिजी ही रहेगा. Okay, server will always be busy because probability that the because rho is 1 means lambda by mu is equal to 1. Lambda by mu is equal to 1 means lambda is equal to mu because जिस रेट से लोग आ रहे हैं उसी रेट से सर्विस हो रही है. अब इस प्रीवियस केस में क्या था? जिस रेट से लोग आ रहे हैं उससे ज्यादा रेट पे सर्विस हो रही थी, सो डेफिनेटली दैट पर्सन एट सम इंस्टेंट विल बी आइडल. ओके, देयरफॉर यहाँ पे क्या था, यूटिलाइजेशन फैक्टर 0.67 था, रो वाज इक्वल टू 0.67, ओके, एंड 1 minus rho, that is 1 minus 0.67, which was equal to 0.33, or 33% was the probability that the server will be idle or free. But here in this case, rho is equal to 1, okay, rho is equal to 1, then probability that the server is not busy will be 1 minus rho, that is 1 minus 1, that is, sorry, 1 minus 1, that is 0%. Okay, the server will always be busy. Okay, see here, sometimes the question is asked, what is the probability that a new customer entering has to wait? Okay, कोई एक नया कस्टमर आ रहा है, व्हाट इज द प्रोबेबिलिटी कि उसको इंतजार करना पड़े? उसको इंतजार करना पड़े मींस वो कब इंतजार करेगा? जब सर्वर बिजी होगा। ओके, प्रोबेबिलिटी दैट द न्यू कस्टमर एंटरिंग हैज टू वेट, एक नया कस्टमर आ रहा है, उसको वेट करना पड़ रहा है। उसको वेट किस सूरत में करना पड़ेगा? जब सर्वर बिजी होगा। ओके, सो दिस indirectly say that what is the probability that the server is busy, और सर्वर की probability, बिजी होने की probability क्या हमें देता है? That is given by the term rho, that is equal to lambda by mu. Okay, so sometimes there is a twist in the question that what is the probability that the new customer entering has to wait? So it is not nothing new. It is simply equal to rho, which is given by the ratio of arrival rate to the service rate. Okay, because a new person entering has to wait. उसको wait करना पड़ेगा because server is busy. So server is busy. Probability कौन देता है? That is given by rho. Okay. Sometimes it's asked in the question that what is the probability that there are zero customers in the system? Okay, suppose what is the probability that there are zero customers in the system? So सबसे पहले हम बात करते हैं सिस्टम की। See here, there are few people, they are waiting in the queue. Okay, there is one person who is getting serviced. Okay, there is one person who is getting serviced. यहाँ पे चार लोग क्यू में बैठे हैं। यहाँ पे एक सर्वर है। This is a server. Okay, he is serving this customer. Okay, he is serving this customer. तो यहाँ पे चार लोग किसमें हैं? क्यू में बैठे हैं, एक का सर्विस हो रहा है। ओके, दिस इज द सर्वर प्रोवाइडर, ही इज सर्विंग वन ऑफ द कस्टमर्स। ओके, तो अगर हम सिर्फ इस पोर्शन की बात करें, सिर्फ हम इस पोर्शन की बात करें, दिस थिंग इज नोन एज क्यू। और अगर हम इस पोर्शन की बात करें, दिस कंप्लीट इज नोन एज सिस्टम। ओके, सो क्यू only includes those people which are waiting, okay, which are not getting serviced. Okay, अभी इनकी सर्विस नहीं हो रही है। लेकिन अगर हम एक कंप्लीट सिस्टम की बात करें, सिस्टम इंक्लूड्स द पर्सन विच द पीपल विच आर वेटिंग इन द क्यू एज वेल एज दैट पर्सन विच इज करंटली गेटिंग सर्विस्ड। ओके, सो probability that there are zero customers in the system, probability that there are zero customers in the system, कब कोई कस्टमर सिस्टम में नहीं होगा, that indicates that it is talking about the probability that the server is idle. Okay, it indirectly gives us the indication that probability that there are zero customers in the system means that the server is idle. जब कोई सिस्टम में नहीं होगा, दैट इज ना ही कोई क्यू में है, ना ही किसी की सर्विस हो रही है, तब सर्वर क्या होगा? उस टाइम सर्वर विल बी आइडल, and that probability is given by what? That probability is given by 1 minus rho. Okay, this is another way a question may be asked. Okay, probability that there are zero customers in the system, that means, okay, that means uh, a probability that the server is idle, and the probability that the server is idle is given by 1 minus rho. Okay, सो यही चीज कभी ऐसे भी दी होती है. This term will also have the same meaning, that probability that a new customer entering does not have to wait. एक पर्सन आ रहा है और उसको वेट करने की जरूरत ही नहीं पड़ेगी. ओके, ही विल डायरेक्टली गेट सर्विस्ड. कब उसको वेट करने की जरूरत नहीं पड़ेगी? जब सिस्टम में कोई पर्सन ना हो. तो सिस्टम में कब कोई पर्सन नहीं होता है? जब एक सर्वर आइडल होता है. और सर्वर आइडल होने का प्रोबेबिलिटी क्या है? 1 - रो. ओके, 1 - रो. सो जो ये टर्म पी नॉट है, दिस टर्म पी नॉट विच इज इक्वल टू 1 - रो, दैट इंडिकेट दैट हैज वेरियस मीनिंग्स. ओके, कभी हम क्वेश्चन में होगा प्रोबेबिलिटी दैट देयर इज नो कस्टमर इन द सिस्टम. Okay, or probability that there are zero customers in the system, that also means p naught. that that indirectly means that the server is idle. तो कभी क्वेश्चन में होगा that a probability that the new customer entering does not need to wait, उसका मतलब भी इनडायरेक्टली है कि सिस्टम में कोई पर्सन नहीं है. और जब सिस्टम में कोई पर्सन नहीं है तो उसका मतलब है सर्वर इज आइडल. सो दिस अगेन गिव्स द प्रोबेबिलिटी दैट द सर्वर इज आइडल. लेकिन प्रोबेबिलिटी दैट अ न्यू कस्टमर एंटरिंग हैज टू वेट, उसको वेट करना कब पड़ेगा? जब सर्वर आइडल नहीं होगा लेकिन बिजी होगा. एंड द प्रोबेबिलिटी दैट द सर्वर इज बिजी इज गिवन बाय व्हाट? दैट इज गिवन बाय दिस टर्म प्रो. Okay, there's one formula that probability that there are n customers in the system, probability that there are n customers in the system, that is given by, okay, I will directly write the result. So the probability that there are n customers in the system, okay, there are n customers in the system is given by Pn, P subscript n, and it is equal to rho raised power n into 1 - रो. या इसको हम इस टर्म में भी लिख सकते हैं that Pn is equal to probability that there are n customers in the system, that is equal to rho raised power n. 1 - रो, we know that it is equal to P naught, that is the server is idle. So this is quite important relation which gives us probability that there are n customers in the system. Okay, इसकी जो derivation है, I will upload another video. Okay, I will upload another video where I will only discuss the derivation, but that is not important from the examination point of view. From the examination point of view, you can directly remember this equation. Okay, this equation is important, but its derivation isn't important. But still, I will upload the derivation. You can see how this equation is coming. Okay, so this is one important formula. Okay, another formula is of the average length of the queue. Okay, so the average length of the queue is given by, okay, so first of all, we'll write the formula for the average length of system. Or it also means the average number of people in the system. Okay, average length of the system or average number of people. ठीक है, तो length of the system doesn't mean how long is the system. इसका कोई यूनिट मीटर या किलोमीटर नहीं होता है. लेकिन इसका मतलब क्या है कि सिस्टम में कितने लोग हैं. ओके, सो कितने लोग हैं सिस्टम में, दैट इज गिवन बाय the formula for it is first of all represented by ls, and it is equal to rho divided by 1 - रो. So this is the formula for what? Average length of the system. Okay. And similarly for the queue. Okay. Average length of queue or average number of people in the system. Average number of people in the system, that is given by LQ. Okay, length of the queue, that is equal to rho square 1 minus rho. Okay, again these two formulae are quite important. Okay, then there are two more formulae which we need to remember. That is the waiting time in the system. Okay, it is the waiting time in the system. So this waiting time in the system is given by, it is the product of two quantities. The first quantity is, it is equal to lambda. Okay, actually this length of the system, okay, it is equal to lambda multiplied by the waiting time in the system. Okay, and length of the queue is also equal to lambda times the waiting time in the queue. Okay, so from here actually we will get waiting time in the system is equal to ls by lambda, and from here we will get the waiting time in the queue. Okay, rather the average waiting time in the queue, that is lq by lambda. So these have been derived from a law which is known as Little's law. And what does Little's law give us? It gives us the relation between the okay, it gives us the relation between the length of the system and waiting time in the system. Okay, so let's recall the formulae which we have learned, and we will use them in the questions. First is traffic intensity or utilization factor or utilization ratio, that is equal to lambda by mu. Okay, it also represents that the probability that the server is busy, or it will also represent that the probability that the new customer arriving has to wait, because a person has to wait when the server is busy, and obviously the server is busy, the probability is given by the utilization factor. Okay, uske baad humne padha that probability that there are zero customers in the system, that there is no customer in the system, or the server is idle. Okay, that is given by 1 minus rho. It gives the probability that there is zero customer in the system, or probability that a new customer arriving does not have to wait. Does not have to wait means the server is idle. Okay, उसके बाद हमने क्या पढ़ा? We studied the length of the queue. Length of the queue is given by rho square 1 minus rho. Length of the system is given by rho 1 minus rho. Okay, and recently here waiting time in the system ls by lambda. Okay, and waiting time in the queue is given by LQ by lambda. Okay, so अगर हम ये relation देखें, okay, let's take the example of this relation, waiting time in the system. Waiting time, time means hour, minute. Okay, let's look at the unit. Length of the system divided by lambda. Length of the system means how many customers are there in the system. Okay, length of the system means how many customers are there in the system. Therefore, the numerator is going to have the unit of customer, whereas lambda is the arrival rate. कितने customer आ रहे हैं per minute or per hour. Okay, so customer and customer cancels. This goes into the numerator, and the this unit is hour, or it could have been minute. Okay, had this been in the customers per minute. Okay, So we get the waiting time, the unit is hour, minute. Okay, जिस हिसाब से question में दिया हो. Okay, so let's go to some questions. Okay, so if we look at this question, the number of persons arriving at a service center is 8 customer per hour. So arriving, okay, since it is talking about arriving, therefore 8 customers per hour. See, the unit is customer per hour. Okay, तो customer per hour जब होगा या तो ये होगा arrival rate या होगा service rate. ये इंटर अराइवल या इंटर सर्विस रेट नहीं हो सकता है बिकॉज उसका यूनिट जो है दैट इज आवर्स पर कस्टमर और मिनट्स पर कस्टमर. ओके, so from the question it is clear that this is equal to lambda, that is lambda is equal to 8 customer per hour because it is talking about the arrival. Okay, the number of persons arriving at a service center is 8 customer per hour and the service provider takes 5 minutes per customer on an average. Now this is very important. Okay, see, 5 मिनट लगते हैं एक सर्विस पर्सन को. ओके, देखिए एक कस्टमर आया 5 मिनट के बाद दूसरे कस्टमर की सर्विस होगी. सो हाउ मच टाइम इट इज टेकिंग? द सर्वर इज टेकिंग 5 minutes per customer, okay, to provide the service. Now 5 minutes per customer, okay, minutes per customer has to be either inter arrival or inter service. Okay, customer per hour is arrival or service rate. Okay, it is lambda or mu, but from the question it is clear that it is lambda. Whereas सर्विस की बात हम करते हैं, the unit is minutes per customer, so therefore this is not the service rate but it is the inter service rate which is given here, that is equal to 5 minutes per customer. Okay, the service provider takes 5 minutes per customer on an average. जो सर्विस देता है उसको कितना लगता है? 5 मिनट एक कस्टमर को. Okay, therefore uh, the service rate is, it is not the service rate, it is the inter service rate, that is 5 minutes per customer. Okay, therefore it will be equal to 1/5. अगर हम इसकी बात करें, किसकी बात करें? सर्विस रेट की. ओके, 1/μ इज 5, सो म्यू विल बी 1/5 और इसका यूनिट जो होगा दैट विल बी कस्टमर पर मिनट. यहाँ पे क्या दिया है? मिनट पर कस्टमर, तो इसका रेसिप्रोकल जो होगा, ओके, दैट इज द सर्विस रेट, दैट विल बी 1/5 कस्टमर पर मिनट. बट सिंस वी हैव टू फाइंड आउट रो, रो इज व्हाट? रेशियो ऑफ lambda by mu. Okay, सो द यूनिट शुड बी कंसिस्टेंट. जो न्यूमरेटर में यूनिट होगा वही डिनोमिनेटर में भी यूनिट होना चाहिए. ओके, अगर न्यूमरेटर में कस्टमर पर आवर है तो यहाँ पे भी क्या होना चाहिए? म्यू का यूनिट भी कस्टमर पर मिनट होना चाहिए. ओके, सो यू कैन कन्वर्ट दिस इनटू द आवर्स बाय मल्टीप्लाइंग इट विद 60, isn't it? Because there are 60 minutes per hour. So this is actually what? Customer per hour. एक मिनट कितना आवर्स होता है? एक मिनट इज इक्वल टू 1 minute इज इक्वल टू 1/60 hours. Okay, that will be equal to, ये 60 न्यूमरेटर में जाएगा, 60/5 customer per hour. Okay, that is 12 customers per hour. So you have found out the arrival rate was directly given in the customer per hour. You have, but here the service rate was given at that too in minutes. Okay, minutes per customer. So inter service rate was converted into service rate and that was service rate in customer per minute, but we further converted it into customer per hour by multiplying it with 60. Okay, so अगर ये क्वेश्चन में पूछता what is the probability that the server is busy, the probability that the server is busy, okay, p busy is given by simply the utilization factor, that is lambda by mu. That will be equal to 8/12, that will be equal to 2/3, that is equal to 0.67. So the probability that the server is busy is 0.67 and the probability that the server is idle is given by 1 minus rho. Probability that the server is idle, probability that the server, that the new customer does not have to wait, or the probability that there are 0 customers in the system, ये तीनों क्या होते हैं? 1 minus rho. Okay, represented by p naught, that is given by 1 minus 0.67, that is 0.33. Okay, but here in the question find the length of the system and q. Length of the system, ls, is equal to rho divided by 1 minus rho, that is equal to rho is given by what? Rho is 2/3 divided by 1 minus 2/3. So this will be actually equal to 2 by 3 divided by 1 by 3. Okay, that will be equal to 2. That is, there are two people in the system. Okay, there are two people in the system. Okay, now if we want to find out the length of the queue, कि queue में कितने person है, obviously queue में जो लोग होंगे, that will be less than the number of person in the system, because system includes number of people in the queue as well as in the one which is getting serviced. जो लोग वेट कर रहे हैं और जिनकी सर्विस हो रही है, कलेक्टिवली उनको हम सिस्टम कहते हैं, लेकिन क्यू में वो नहीं इंक्लूड होगा जिसका सर्विस होता होगा. दैट्स व्हाई this LQ will be definitely less than 2. Okay, so you can see here it is given by rho square. अभी हमने फॉर्मूले पढ़े थे. So this will be 2 by 3 square divided by 1 minus 2 by 3. That will be equal to 4 by 9, in fact, divided by this will be 1 by 3. So this will be equal to 4 by 3, and it is equal to, I think, 1.33. So you can see that this LQ comes out to be less than the LS, okay, as was expected. Waiting time in the queue and system. Waiting time in the queue is given by, oh, this waiting time in the queue is given by LQ by lambda, okay. LQ जो अभी हमने निकाला, that was equal to 4 by 3. There are 4 by 3 customers, okay, and lambda is the arrival rate, that is 8 customers per hour. Okay, customer and consumer will this cancel out. We will have this will be equal to waiting time in the queue. Okay, so this will, after okay, 4 divided by 3 multiplied by 8, that will be equal to 24. So this will be equal to 4 by 24 hours, or this will be equal to 1 by 6 hours. Okay, so waiting time in the queue is equal to 1 by 6 hours. Okay, if we want to represent it in terms of minutes, we will represent it 1 by 6. एक hour में 60 minutes होते हैं. Therefore, this waiting time in the queue is equal to 6 by 10, that is 60 by 6, that is equal to 10 minutes. अगर हम waiting time in the system की बात करते हैं, that is given by length of the system divided by lambda. Length of the system we had calculated as 2. Okay, so length of the system means 2 customers. This again means 2 customers. So it is equal to 2 customers divided by lambda is equal to 8 customer per hour. This is equal to 1 by 4 hours. और एक आवर में कितना एक घंटे में कितने मिनट्स होते हैं, that is 60. So waiting time in the system is equal to 15 minutes. Okay, obviously waiting time in the system queue से ज़्यादा होना चाहिए waiting time in the queue, because waiting time in the system means कि कुछ टाइम के लिए ये क्यू में था और कुछ टाइम में इसकी सर्विस भी हो रही थी, लेकिन क्यू में क्या है, ये कितने टाइम क्यू में वेट कर रहा था. ओके, obviously that won't include the time which is the time required for the service. Okay, so this was one simple problem. Let's look at one more problem. Let's look at this question. A shopkeeper serves 10 customers per hour. Okay, एक shopkeeper सर्व करता है. Okay, 10 customers per hour. So ये किसकी बात कर रहा है, ये सर्विस की बात कर रहा है, और कस्टमर पर आवर यूनिट दिया है, that is he is talking about the service rate. And customers arrive at the rate of 7 per hour. It's very easy, that it is equal to lambda is equal to 7 customers per hour. Find the probability that there are 3 customers in the system. हमने अभी देखा कि probability that there are n customers in the system or n people in the system is given by rho raised power n divided by 1 minus rho. Therefore हमें किसके लिए निकालना है, here n is equal to 3, therefore rho is equal to, rho की अगर हम बात करें यहाँ पे, that it is equal to lambda by mu. अब दोनों के यूनिट सेम है, देखिए ऊपर भी कस्टमर पर आवर है, यहाँ पे भी कस्टमर पर आवर है, therefore we can directly take the ratio that is equal to 0.7. So rho is equal to 0.7. यहाँ पे n का वैल्यू क्या है, 3 है. So 1 minus rho, that is 1 minus 0.7. So probability that there are 3 customers in the system, अगर हम इसका evaluation करते हैं, this comes out to be 0.1029. Okay, calculation portion still you check from your side, but it comes out to be 0.1029. Another thing is that find the probability that there are at least 3 people in the system. So see here, what is the difference? Find the probability that there are 3 customers in the system. Find the probability that there are 3 customers in the system. That is, there are exactly 3 customers. Okay, ये formula किसके लिए है? This formula is for exactly n number of customers. Okay, find the probability that there are exactly 3. 3 तो बराबर क्या probability है that there are 3 people in the system. लेकिन ये जो कह रहा है यहाँ पे that there are at least 3. At least 3 means क्या? कम से कम 3 भी हो सकते हैं, 4 भी हो सकते हैं, 5 भी, 6 भी, 7 भी, 8 भी, 10 भी, लेकिन कम से कम 3 होने ही होने चाहिए. ओके, सो इस सिचुएशन में क्या हम करते हैं, लॉ ऑफ प्रोबेबिलिटी यूज. We know that probability of 0 customer in the system plus probability of 1 customer in the system, probability of 2 customers in the system, plus probability that there are 3 customers in the system, plus probability that there are 4 customers in the system, plus probability that there are 5 customers, probability that there are 6 customers, and so on. That has to be equal to 1. Okay. Now probability that there are at least 3 customers in the system means या तो 3 या तो 4 या तो 5. So actually we have to calculate this term. ठीक है, probability that there are 3 customers in the system, at least 3 means what? It can be 3, it can be 4, it can be 5, it can be 6, and so on. That will be equal to 1 minus p naught. सॉरी, लेफ्ट हैंड साइड जाके ये सारा माइनस हो जाएगा. ठीक है, ये टर्म ये टर्म ये टर्म लेफ्ट हैंड साइड में आएंगी. सो दिस विल बी इक्वल टू 1 माइनस पी नॉट इज इक्वल टू 1 माइनस रो, और ये जो p1 होता है इट इज इक्वल टू रो रेज पावर 1. 1 माइनस रो minus this p raised power, sorry, this probability that there are 2 customers in the system. This is probability that there are 0 customers in the system, that is given by 1 minus rho. Probability that there are 1 customer in the system is given by rho 1 minus rho. Probability that there are 2 customers in the system, rho raised power 2 1 minus rho. ठीक है, सो यहाँ पे क्या होगा, 1 माइनस, यहाँ पे आप देख सकते हैं 1 माइनस रो कॉमन आ जाएगा, isn't it? So in brackets we will have 1 minus rho square. Okay, so this is 1 minus rho here is 0.7. So this is 1 minus 0.7 minus 0.7 square. So ये probability किसमें अगर हम इसका evaluation करें, still you try to evaluate from your side, this comes out to be 0.343. Okay, I expect you to calculate this yourself again just to check the calculations. Let's move on to some more questions. So let's look at this question. At a telephone booth, arrival of a customer follows poison process with an average inter-arrival time of 10 minutes. Okay. So यहाँ पे क्वेश्चन में सीधा कहता है that एक टेलीफोन बूथ है, वहाँ पे people are arriving, okay, to make a phone call, and the average inter-arrival time is 10 minutes. Okay. So actually this is not the arrival rate, it is the inter-arrival rate. Okay, कि 10-10 मिनट के बाद एक कस्टमर आता है. Okay, so this is actually 10 minutes per customer. Fine. Again, look at the question. At a telephone booth, arrival of the customers follows poison process. Okay, मैंने कहा है poison process होता है, मतलब जो arrival pattern होता है that is poison. Okay, arrival rate is poison, but inter arrival is what? Inter arrival is exponential. with an average inter-arrival time. Okay, inter-arrival का जो time है that is 10 minutes. Okay, average inter-arrival time is 10 minutes. That is 10 मिनट के बाद एक कस्टमर आता है. That is 10 minutes per customer. It takes 10 minutes per customer to arrive. So if we talk about lambda, it will be equal to, okay, this is inter-arrival, this lambda will be arrival, and arrival will be equal to the reciprocal of arrival. Okay, so arrival will be equal to reciprocal of inter-arrival, that is it will be equal to 10 1 by 10, not minutes per customer but customers per minute. The length of the phone call is exponentially distributed with a mean of 3 minutes. अब length of phone call is exponentially distributed. देखिए सर्विस के लिए कौन आ रहे हैं सर, सॉरी अराइवल्स कौन है, पीपल, एंड द लेंथ ऑफ द फोन कॉल इज एक्चुअली द सर्विस. ओके, देखिए यहाँ पे सर्विस प्रोवाइडर कोई ह्यूमन बीइंग नहीं है. ओके, यू कैन सी दैट दिस इन दिस केस द सर्विस प्रोवाइडर इज द टेलीफोन. ओके, टेलीफोन सर्विस प्रोवाइडर है. सो द लेंथ ऑफ द फोन कॉल is exponentially distributed with a mean of 3 minutes. 3 मिनट्स लगते हैं सर्विस को, दैट इज फोन कॉल में कितना टाइम लगता है, 3 मिनट. तो 3 मिनट के बाद दूसरा कस्टमर का सर्विस होगा. ओके, एक कस्टमर आ रहा है, वो 3 मिनट कॉल कर रहा है, उसके बाद नया कस्टमर 3 मिनट के लिए कॉल कर रहा है. ठीक है. सो अगेन रीड द स्टेटमेंट, द लेंथ ऑफ द फोन कॉल इज एक्सपोनेंशियली डिस्ट्रीब्यूटेड with a mean of 3 minutes. Okay, length of the phone call. यहाँ पे phone call is the service. जो लोग आ रहे हैं, these are the arrivals. जो लोग आ रहे हैं टेलीफोन बूथ पे, these are the arrivals. And the length of the phone call यहाँ पे service है. The length of the phone call is distributed exponentially with a mean of 3 minutes. 3 मिनट के बाद फोन कॉल सर्विस हो रहा है. दैट इज 3 मिनट के बाद, जैसे एक कस्टमर की सर्विस होगी, 3 मिनट के बाद दूसरे कस्टमर की सर्विस होगी. अब यहाँ पे सर्विस क्या है, phone call. Okay, services phone call. So length of the phone call is exponentially distributed with a mean of 3 minutes. So again, it is not the service rate, but it is inter service rate, which is 1 by mu, which is equal to 3 minutes per customer. Okay, 3 मिनट के बाद एक एक कस्टमर को सर्विस मिल रही है. Okay, so this is the inter arrival. So arrival will be the reciprocal of this, that will be equal to 1 by 3 customers per minute. Okay, it will be equal to 1 by 3 customers per minute. So अगर हम इसमें यूटिलाइजेशन रेशियो निकालें, that will be equal to lambda by mu, that will be equal to 1 by 10 divided by 1 by 3, that will be equal to 3 by 10, that will be equal to 0.3. Okay, so this gives us the probability that the server is busy. Okay, or it gives us the probability that the new customer arriving has to wait. It has to wait because the server is busy. Okay, probability that there is no customer in the system, or probability that the server is idle, that is given by 1 minus rho, that is given by 1 minus 0.3, that will be equal to 0.7. Okay, अगर यहाँ पे पूछता है length of the system निकालो, then it will be equal to rho divided by 1 minus rho, that will be equal to 0.3 divided by 1 minus 0.3, that is equal to 0.3 divided by 0.7, that is equal to 3 by 7. अगर पूछ रहा है length of the queue निकालो, that is equal to rho square divided by 1 minus rho, and that will be equal to 0. Rho is 0.7. Okay, 0.7 square divided by 1 minus 0.7. Okay, sorry, this rho is 0.3. Okay, so this will be equal to 0.3 square divided by 1 minus 0.3. Okay, so this will be equal to 0.3 square divided by 0.7, that will be equal to 0.128. Okay, still calculate from your end as well. So अगर waiting time का पूछ रहा है, okay, अगर probability that there are two customers in the system पूछ रहा है, okay, then the probability that there are two customers in the system is rho square multiplied by 1 minus rho. So it will be equal to 0.3 square. Okay, you can calculate its value. Okay, अगर लिटल्स लॉ का यूज कह रहा है तो लिटल्स लॉ के यूज से हम क्या निकाल सकते हैं, वेटिंग टाइम इन द सिस्टम दैट विल बी गिवन बाय ls divided by lambda. Okay, so ls हमने अभी देखा था, the length of the system is given by, let's say, equal to 0 3 by 7. Okay, that's equal to 3 by 7. और यहाँ पे जो अराइवल रेट था दैट वाज इक्वल टू 1/10 मिनट्स. ओके, सो ऊपर क्या है, ऊपर का यूनिट है कस्टमर, यहाँ पे है कस्टमर पर मिनट. तो जब हम इसको सॉल्व करेंगे दैट विल बी इक्वल टू, you can see that will be equal to 30 by 7 minutes. Okay, and that will be equal to 4.28 minute. Similarly, if you want to calculate the waiting time in the queue, then as per Little's law, this relation holds, and we will get that the waiting time in the queue is equal to, and that will be equal to length of the queue. इससे पहले हमने देखा था the length of the queue is equal to 0.128. Okay, length of the queue means how many customers are in the queue, and this is the arrival rate. Okay, so this will be equal to, okay, multiplication, that will be equal to 1.28 minutes. Okay, so this is how we solve various problems. Okay, so there's a Kendall representation for queuing model, or in other words we can say the nomenclature for queuing model. So इसका जो representation होता है that is given by a slash b slash c. This is how a queuing model is represented. जो हमने अभी तक queuing model पढ़ा, that was, okay, let's see what are the various terms. A gives us the arrival distribution, B gives us the departure distribution. ठीक है, so हमने जो distribution पढ़ा था, A means the arrival distribution and B means the departure distribution. जो हमने पढ़ा था उसमें क्या था, the arrival was Poisson and the departure distribution was negative exponential. जब ऐसा डिस्ट्रीब्यूशन होता है तब हम जो मॉडल पढ़ रहे हैं दैट इज मार्कोवियन अराइवल. ओके, दैट इज मार्कोवियन अराइवल और डिस्ट्रीब्यूशन, और इन दोनों को रिप्रेजेंट किया जाता है m से. सो m/m. ठीक है, व्हाट डज c रिप्रेजेंट, नंबर ऑफ सर्विस चैनल्स. ओके, कितने सर्वर्स हैं यहाँ पे. ओके, नंबर ऑफ पैरेलल सर्विस चैनल्स. सो हमने सिंगल सर्वर मॉडल पढ़ा था, जो भी हमने रिलेशंस पढ़े थे वो सिंगल सर्वर के लिए थे. ओके, ऑल दोस आर इन्वॉल्विंग ए सिंगल सर्वर. ओके, व्हाट डज डी गिव अस, डी गिव्स अस द सर्विस डिसिप्लिन. जो हमने अभी तक मॉडल पढ़ा था वो हमने पढ़ा था फीफो, फर्स्ट इन फर्स्ट सर्व. मैक्सिमम नंबर ऑफ कस्टमर्स इन्वॉल्व्ड अलाउड इन द सिस्टम, जो हमने पढ़ा अभी तक, जो रिलेशंस वो इनफाइनाइट के लिए पढ़ा. और एफ इज द कॉलिंग सोर्स ऑफ पॉपुलेशन, कॉलिंग सोर्स और पॉपुलेशन जो है वो भी क्या है, इनफाइनाइट. सो दिस इज द एक्चुअली द मॉडल विच वी हैव स्टडीड. जो भी हमने रिलेशंस पढ़ी है वो किस मॉडल के लिए हमने पढ़ी है, दिस मॉडल. ठीक है, बिकॉज हमने क्या पढ़ा, A, okay, A gives the arrival pattern. Arrival pattern for hour is Poisson, and B gives the departure pattern or the service pattern. That is again negative exponential. When arrival and the service are Poisson and the exponential respectively, then that is known as what, Markovian, and it is denoted by M. Okay. कहीं पे क्या होता है, गामा अराइवल और सर्विस होता है, तब जाके क्या हम कहते हैं, दैट इज एन एयरलाइनजियन मॉडल. ओके, समटाइम्स डी, अगर कहीं पे डिटर्मिनिस्टिक अराइवल और डिपार्चर है देन दैट मॉडल विल बी डी डी. ओके, अगर वहां पे दो सर्वर्स है वहां पे टू होगा उस मॉडल का. अगर वहां पे सिरो हो रहा है, SIRO, और वहां पे इनफाइनाइट इनफाइनाइट कैपेसिटी है और कॉलिंग पॉपुलेशन इनफाइनाइट है, तब जाके हम उस मॉडल को ऐसे लिख सकते हैं. तो ये क्या है, दिस इज अ काइंड ऑफ अ नॉमेनक्लेचर. ठीक है, सो अगर आपको कहेंगे कि आपको आपके सामने ये क्यूइंग मॉडल रखेंगे, आपको बोलेंगे कि डिकोड करो व्हाट इज योर क्यूइंग मॉडल। आप देखोगे एम, एम मींस यहाँ पे क्या है, दिस इज ए बी सी डी ई एफ। सो ए एम, ए क्या है यहाँ पे, एम, एम मींस व्हाट, मार्कोवियन, मार्कोवियन मींस दैट पॉइजन अराइवल। बी क्या है, एम मींस मार्कोवियन, B means service, so Markovian service means it's negative exponential service. Okay, number of servers, C means number of servers, यहाँ पे 1 लिखा है, C is equal to 1, आपके यहाँ पे एक सर्वर है। D FIFO लिखा है, that is service rule कैसा है, first come first serve. Okay, E is the capacity of the system or maximum number of people allowed in the system, ये infinite capacity है यहाँ पे। अगर आपको कहेंगे कि calling source population कितना है, okay, that's again infinite because F is equal to infinity. Okay, so this is how we represent what the Kendall's notation for the queuing model. Again, C and D किस लिए है, service rule. Okay, it can be first come first serve, last come first serve, zero or general rule. Okay, E and F you can read this. Okay.